Alright, 8th grade, let's set up really quickly for investigation 2.3. Basically what we have here, I'm on page 23 looking at the getting ready for the problem. A new rectangle is made by increasing one side of a square with sides of length x by 2 centimeters and increasing the other side by 3 centimeters. So basically what happens is you have this rectangle, or the square that's x by x, and you take that x by x and you expand on it. And again, my drawings are not to scale. So basically what we have is 2 units added to this side, and then we have 3 units added to this side. So basically what's happened is, unlike yesterday where you had only 2 parts of a big rectangle, now you end up having 4 parts of a big rectangle. So how do the areas of the square and the new rectangle compare, and then how can you represent the area of the new rectangle? Well, I just kind of talked about how they compare. We have our original x by x in there. We've added some dimension to the length, and we've added some dimension to the width. So same sort of thing as yesterday. I can think of my area as length times width. I can also think of my area as a sum of areas. So if I have different parts within a rectangle, I can add up all the different parts and have it there. So if I was looking at area length times width, I have 2 situations happening here. So for the width, I'm looking at x plus 3. And then for the length, I have my x plus 2. So if I was going to write that, I would have area is equal to x plus 2 times x plus 3, or vice versa. Those through commutative property of multiplication. Is that right? Yeah. You can flip-flop those and it still works out. If I was taking the sum of all of the areas, I would have something that looks like this. And I color-coded them the other day. Should I do that now? Sure, why not? All right, so basically I have this square here, which is x squared. We'll make that green. So my area here, I could represent that as x squared. Then I have this section here, which is 2 times x, or 2x. So plus 2x. I have an area up here, which is 2 times 3. So 2 times 3, which is equal to 6. I'm going to put that at the end. I'm going to do the last one, and then I'll put the other one. And then I have this one, which is 3 times x. So these 2 right here. So 3x. I'm going to go in order, just as we've talked about in our polynomial packet. My highest exponent, and then I should go lower if I'm going to put it in correct order. So I've got x squared plus 2x plus 3x. And then at the very, very end, I have my 2 times 3, which I can represent as plus 6. So this ends up being my new area there. So that is the expectation for today. Obviously, if we were combining like terms, the 2x and the 3x could be combined to simplify it, but this is what we're looking at today. You have some rectangles to draw today. You have the 2 different expressions that you'll have to write, and you're supposed to use your rectangles to help you out. Good luck. If you have questions, come and see me. Bye-bye.